Like I said, today's going to be a lot about vocabulary and understanding how to name things, how to say things in geometry. Because even though we're familiar with these things in the real world, we've seen these things, we've worked with them before, we just need to make sure that we are able to identify them all the same in this class. So the first one we're going to talk about is line, which we've already talked about. What would be our definition of a line? How would we describe a line? Good, it's straight. What else do we know about a line? Goes on forever. Forever and ever and ever. I'm going to say never ending, but if you would like to say it goes on forever, you can say that also. Okay, or if you want to say infinite or extends, I don't know, whatever you want. Okay, so I'm going to use one of my color pencils for this. I'm going to just use this line in the background to show my nice straight line. So there's my straight line. And then how do I show that it's never ending? Arrows, good. Okay, now when we name a line, there's a couple ways we can do it depending on what we're given. If we have a lowercase next to it, we could just call it whatever that lowercase is. Call it good. Okay, but here we aren't going to have that. We're going to have points. So we're going to have 1 point here. Let's call that point C. And we'll throw another point here. We'll call that H. The music is so loud, bro. Okay, so when we look at this name, we name those points that it goes through. So what points does this line go through? CH. But how do I tell my readers that this isn't just 2 points connected, it's a line? Line over the top. Beautiful. Okay, if your color pencil is sharp enough to do that, go ahead and use your color pencil. If it's not, just use your regular pencil. Okay, but putting that line with both the arrows on top is going to tell us that that is a line. Super fancy stuff, I know. All right, next up we have is similar, but we're going to talk about a line segment this time. Good morning, Kaylin. How are you? You sit by Nadira up there. Nadira and Lainey. Okay, so a line segment. If something is segmented, if you're watching a movie segment, what does that mean to watch a movie segment? Apart. Are you watching the whole movie? No, it's just part of it. So same thing with a line segment. We're just going to be doing a part. Okay, so line segment is part of a line, a measurable part. Sorry, that was a new word I added in this year. Measurable part, meaning we can measure it. Amazing. Measurable part of a line. With endpoints. Measurable part of a line with endpoints. So I'm going to grab just a different color here. You can grab a different color. I'm going to use blue. So endpoints means I have a beginning and I have an end. So they're kind of showing the beginning and the end, and then our line segment is still straight and it's just connecting those 2 points. What is happening over there? They're listening to a very loud video. All right, as we look at those endpoints, we have points here, so we need names for those points. In math, we're super creative. What do we use for names? Letters, capital or lowercase? For points, we use uppercase. We use capital, yeah. Okay? Points are uppercase letters. Lines are lowercase. All right, so let's call this one N. And we'll just call this one F. I don't know, I just made those up. Okay, so the name of this one, when we're telling people about this segment, we always have to name the endpoints. Where is it beginning and where does it stop when we're talking about segments? So where is this segment beginning? N. Where is it stopping? F. Now, could you walk this backwards? Could you start at F and walk back to N? Yeah, same thing. So it could be NF or you could say FN. But we need to tell our readers that this is a segment. So above that, we're going to put kind of that straight, it's kind of confusing. I'm going to say straight line, but it's not a line. No arrows. So it starts at N, saying start at N, and then draw straight all the way to end at F. So just a straight line. Okay, the way that we say this is we would say segment NF. Okay, so when you see that written down, we'd say that a segment NF. So whenever we see these symbols, we always read the top symbol first and then the bottom letters. So in this top one here, going back to the last example, this top one is showing us a line. So that'd be line CH. This time it's a segment NF. Okay, now it said it was measurable. So let's say N to F is, I don't know, 5 feet. I'm going to do FT for feet. When we measure it, and this is goofy, I don't know if I 100% understand why we do this. I've just accepted it as part of my life. Okay, the measure we just say NF. From N to F equals 5 feet. So that's a little different. When we look at the name of it, if I'm saying look at this segment, I'm talking about this segment. We use that segment above it. But if I'm talking about how far it is, we don't put the segment line above it. It's just from N to F is 5 feet. Okay? That takes a little while to get used to of when do we put that line there, when we not. I don't know. It's a little goofy. Okay, we have 2 more words. I know today is really vocab heavy. Next word is, it's a phrase. I don't know what this is. It's in vocabulary. It's called betweenness of points.
All one word?
No, 3 words. Betweenness of points. According to math it is. Let's see if it pops up on Google. Yeah, betweenness is a word. May refer to the ternary relation of intermediacy or betweenness. It uses the word betweenness in the definition. Can't use that, right? Okay, what does it mean if you are between something? I'm between jobs. You're in the middle. I had one job. I stopped that job. I haven't gotten my new job. I'm in the middle of that. Okay, if I look between me and Lainey, Lainey's up in the front in the lovely brown shirt there. Who's between Lainey and I? Lola's between us. Who else is between us? Yeah, Jesus is between us. You're looking at him. Okay, we got lots of people between us. Does between mean it has to be somewhere exactly in the middle? No, just somewhere in that middle. Okay, if I'm between jobs, that might mean I'm starting a job tomorrow. It might mean that I'm starting a job in a month. Okay, it doesn't mean right in the middle. So it's somewhere in the middle of the points. It's just, that's a really goofy definition, but there's not really, I don't know. I read the textbook definition and it's confusing. This one is the one that makes somewhere in the middle. It's not exactly the middle, it's just in between. Okay, so if I draw a picture here, I'm going to have segment KT. So that means at one end I have K, and at the other end I have T. I'm going to put M in between K and T. Now remember, in between doesn't mean it has to be exactly the middle. So I'm going to actually put M closer to K. I want to remind my brain later on today or tomorrow or before the test that between doesn't mean the middle. So I wanted to make it look like it's not the middle. It's just in between. It could be the middle. It could be closer to T. I don't know. Okay, and this brings us to a handy dandy thing that we know, but we just haven't stated in a geometrical way. We know that when I add one part plus the other part, it's going to equal the whole thing. So in this problem here, what is my first part? If I started walking, where would I start at? K. And where would I walk to first? M. So if I have KM, now I take a break at M's house. I say, hey, what's up, M? Let's chill. Let's hang out. Okay? We drink some tea. Okay? And then I continue my journey, and I say, okay, sorry, I gotta go. Bye, M. I'm still at M's house, so I have to start there. Then where can I go after M? To T. Now, even though I paused in the middle at M's house, really, how far did I walk? Where did I really start walking from in the morning? K, and I really walked all the way to T. To show measurements that are kind of longer, that have parts in the middle, we use these brackets a lot of times to show we're going from this part to this part. This is brown. I know it kind of looks like that orange on the screen. Okay, and this again is something that you guys know. You just might not have put it together like this, where you thought, oh, this part plus this part equals the whole thing. All right, one last word, and then we have one example, and then we are done. Okay, this next word is a word that will take you a weird amount of time to memorize, but we use it so much. Like the whole trimester, the whole year, not the whole well, the whole trimester too. Okay, is congruent. Congruent is a big word in geometry. We use it a lot. Congruent. Okay, and today we're going to talk about congruent segments. And congruent segments means that they're the same length. Or that they're equal. All right, so as I take a look at this, we're going to draw a line here, or sorry, segment. We're going to do F to H. Now over here I'm going to do another one. Let's do N. And I'm going to try and measure it about the same, kind of just guess about how long that is on my pencil. That goes to like here. So like here-ish. N to V. Now, I didn't take out a ruler and measure this exactly, did I? Do I know that these are exactly the same? They're exactly equal, the same? I did not know that they're exactly the same, I guessed. Okay, but I'm going to tell my reader that they're exactly the same. There's a couple ways to do it. The first way is by naming the segments. So what's my first segment here? It starts at F, it goes to H, and I'm talking about the segments. I put that little line above it. Okay, and then I say is congruent to. Now the congruent symbol is an equal sign with a little squiggle on the top. The congruent sign is an equal sign with a squiggle on top. Okay, and what is FH congruent to? NV, segment NV. That's one way to tell my reader that they're the same. Another way to tell my reader is by using tick marks, little dashes. Okay, so if I put a little dash here in FH, and I put the same little dash over here with NV, that tells my reader that these two have that same dash. They match. They're the same. Now, if there's a picture or a diagram with lots of congruent segments, we just add on tick marks. The ones match with ones. The twos match with twos. Okay, and what that tells us is that if the segments are congruent, the distances are equal. Okay, remember this part down here, this is the distances, this is the segments. If you want to add that in, you can. You don't have to. That just can be helpful. It means that the distances are equal. If the segments are congruent, the distances are equal. Currently, at this moment in time, being that's our second lesson, you're probably like, why the heck are we saying this? Why can't we just say they're equal? Valid point. Eventually, you'll see why. But today, it's just a new word. All right, we have one example that we're going to do today. And I'm running a little out of space, so I'm going to write my example over here and then write it. Okay. Probably need about 5-6 lines. So if you have 5 or 6 lines, you probably can fit it in. All right, if QT is 3 millimeters, so you're doing mm for millimeters. There wasn't supposed to be a comma there, sorry. It's grammatically incorrect. And PS is 18 millimeters. We need to find PQ. And you're probably like, what the heck is she talking about? PQ. Okay, this one, it comes with a picture. So far, this is not the whole problem. There's still a picture that we need to draw in before we can do it. Okay, this is still a part of the problem. So we're going to draw a segment down here. There's no way you know that. Okay, so then we have P as our starting point. We're going to go all the way to S. We're going to put point Q a little over halfway. And then point T is going to go between Q and S. And we see that we have a tick mark here and a tick mark here. Okay. Now, this would be like on your homework, this is the problem. Okay, so far the rest of that was just us setting up the problem. Okay, so now we need to find PQ. So what I like to do is I like to label my stuff, just helpful. So I'm going to start with QT is 3. So I know from here to here is 3. Okay, P to S is 18. That one, it jumps over points, so I like to use that bracket either above or it could go below. Okay, this is 18. And my goal here is to find PQ. Well, you are. You just didn't. There's no there. You just guessed. You didn't guess, but you got there illogically. It didn't make sense. You didn't know what TS was. I don't know. It's weird. All right. So what do we know? How can we find this PQ? What other part of our diagram have we not really talked about yet? Yeah, TS. What do we see about TS? It has a dash. Good. So what does that dash mean? Means the same as QT. So we can put a 3 here also. And then we know all the parts together make the whole. So question mark plus 3 plus 3 equals, what's the whole? 18. And we're trying to figure out what that question mark is. Now, depending on who you are and your math background, you might guess and check. You might just use Desmos and pull that calculator up and just put in random numbers, see what works. You might put the 3 and 3 together. 3 plus 3 is 6. And what are we going to do to find that question mark? How would I combine an 18 and a 6? Good. So we take the whole minus the part. 18 minus 6 is 12. That is a weird 6. Sorry. So bad. So our whole minus our part. So that's one way to do it. We can think of our parts being added up to the whole, or we can subtract the whole from a part. When we label this as our official answer, we're going to make it look really nice and pretty. We would say PQ, it's a distance, so no line above it, just P to Q, equals 12 what? MM. What does MM mean? Millimeters. It's hoping it'd mean M&Ms. Anyone bring me M&Ms today? Make a happy teacher. Okay. Yay, we did it. Okay, so we do have a little bit of time left today. You